Calculating slope using a table of values. A table of values is used to record the coordinates of points in a relation. A linear relation is a pattern that connects two sets of data, and we express those as an ordered pair as a coordinate x, y. Remember that a linear relation is a straight line. And slope is the rate of change of one point on a line in relation to another point. So we look at, for every unit change of one value, which is the x, we can determine the rate of change in the second value, which is the y. So as x increases, we can find out how much y changes. Now in grade 9, you use table of values to draw straight lines or draw linear relations. You may have also remembered learning about the first differences. So we're going to take this lesson to review that. So we can use a table of values to determine the rate of change, which in grade 9 we call the slope. And we use something called the first differences to find the rate of change. Now remember that difference means subtraction, so that's going to give you the hint in terms of what operation you need to do to find the first differences. So we're going to use this table of values to determine the slope for the relation y equals 3x plus 1. Remember, when we're trying to use an equation to find our x and y values, we choose the values for x that we want to use. We substitute those into the equation for x and we solve for y. So I've already done that for you for the x and y column, and we're going to use the y column to find the rate of change. Now it's very important that your x column needs to go up by the same amount. So you'll notice that these each go up by 1. If they don't, then it's going to make finding your rate of change or your first differences a little bit trickier. So make sure they're going up by a constant amount, preferably 1. So to find the first differences, we take the number in the y column, we take the one below, and we subtract the one above it. So 4 minus 1 is equal to 3. We do that for each set of coordinates. So 7 minus 4 is equal to 3. 10 minus 7 is equal to 3. And lastly, 13 minus 10 is equal to 3. So you'll notice that if the slope is the same for all of the coordinates, or if the rate of change or the first differences, remember that those are all interchangeable, then it's going to have a constant rate of change, which means it's going to be a straight line. So we can use the first differences to tell whether our equation or our relation will be a linear relation or some other relation that we're going to learn later on in this course, like a quadratic relation, for example. So when the first differences are the same, then it means that we're going to have a straight line when we graph it. Let's take a look at some more examples. For example number 2, we're using the table of values to determine the slope for the relation y equals negative 3x plus 4. Again, I've given you the x values and the y values already. But remember that you can find the y values by choosing your values for x, substituting that into the equation, and solving for y. Again, I want to make sure that my x column goes up by a constant amount. So it looks like I'm going up by 1 for each value, which is what I hope to see. And now I'm going to calculate my rate of change. So again, in order to find my rate of change or my slope or my first differences, they all mean the same thing. I take my y column, I take the number below and subtract the number above. So 4 minus 7 is minus 3. Then I do the same thing for each of those. 1 minus 4 is equal to minus 3. And negative 2 subtract 1 is equal to negative 3. So all of my first differences are the same, therefore I have a linear relation. So that's what I want, okay? So the rate of change for linear relations should be the same, or the first differences will be the same for each of those. Now let's take a look at the coefficient of x. Remember, the coefficient is the number directly in front of a variable, and the operation that happens between these two is multiplication. So the number in front of my x, or my coefficient, is -3. Now let's take a look at what we found for the rate of change. What do we notice? Well, we notice that the rate of change, or our first differences, is exactly the same as our coefficient in front of the x. So these two values tell us the same thing. So these both tell us the slope. And when we get more into the equation of a straight line, we're going to realize that this will always be that case. Even if we go back to the first example, and I look at the coefficient in front of the x, and y equals 3x plus 1, look at that. It's exactly the same as my first differences. And that's what we're also going to realize from this. So these are the slope. And remember, we use the letter m to represent the slope. We can use the concept of first differences in some word problems or some real world situations. So we're going to take a look at a couple examples where we're looking at rate of change within word problems. So we're going to use the information below from this table of values to calculate the rate of change. So what we want to do is we want to, again, look at our columns. So your first column will be your x, your second column will be your y. Our first column represents the number of hours worked. This goes up by 1. This is what I want to see. So they all go up by the same amount. And now I can work out my rate of change, or my first differences. So 6 take away 0 is 6. 12 take away 6 is 6. 18 take away 12 is 6. 24 take away 18 is 6. And 30 take away 24, you guessed it, is 6. So we're going to use this information to graph this on a set of coordinates, or a set of axes. So we are going to, well, first of all, we figured out that the rate of change is 6. So that means that when we look at our graph, we're also going to notice that our slope should also be 6. So we're going to do that as well. So I'm going to plot my coordinates. So remember, these are your coordinates. So I have 0, 0. I have 1 and 6. I have 2 and 12. 3 and 18, 4 and 24, which is way up there, and I can't graph 5 because it's off the grid. So we'll notice that when I connect these points, they create a straight line. And if I was to calculate my rate of change from this graph using my rise over my run, I need to think about what I'm going up by for my rise. So my scale on my y-axis goes up by 2s. So 2, 4, 6, 8. So when I'm calculating the difference, I have to make sure that I'm going up by 2s. So 2, 4, 6. So my rise is 6. And my run from 1 to 2 is 1 unit. So my slope of this line is rise over run, which is 6 over 1, which reduces down to just 6. So my slope from my line is exactly the same as the slope, or the rate of change, that I figured out from my table of values. And so I know that this is going to be a straight line, and these two are exactly the same. And let's do one final example. A downtown parking garage charges $2.50 per hour to park. We want to create a table of values that shows the total charges for up to 5 hours of parking. We want to determine the rate of change, and we want to create a graph. So my number of hours, I can see here that I'm going up by 1s. which is what I want. So this is my X column, and I'm going to calculate my Y column, my total charges. So if I park for 1 hour, I'm going to be charged $2.50. If I park for 2 hours, I'm going to be charged $2.50 times 2, which gives me 5, or $5. For 3, I'm going to add another $2.50 to that to get $7.50. For 4 hours, I would be charged $10. And for 5 hours, I would be charged $12.50. So I'm going to take a look at what my rate of change is. So I'm taking my Y column, I'm subtracting the one from the bottom, and I'm subtracting the one above that, which gives me $2.50. Do the same thing for all of these. And I notice I get $2.50. So this shows me that my rate of change is $2.50 per hour, which is what we expected anyways, because that is how much it is per hour in our question. So let's go ahead and graph that. So because my rate of change is constant, this should produce a straight line. So I'm going to take my coordinates and I'm going to go ahead and plot those. My X is my horizontal axis and my Y is my vertical axis. And I'm going to decide what I want to go up by. So I'm going to go up by ones for my X. So 1, 2, 3, 4, 5. I spread that out so I can, not have it so squished. And in my Y axis, I'm going to go up. I can even go up by 250 because that is a consistent amount. So I can start at 0 and I can go 250. I can go 5, 750, 10, and 1250. So now when I plot my coordinates, 1 and 250, 2 and $5, 3 and $7.50, 4 and $10, and 5 and $12.50, I notice that when I connect to these points, it creates a straight line. If you have any questions about this lesson, please reach out to me, send me an email, or sign up for a virtual help session, and I will see you in the next lesson.